So in the past, business in space was all about the movement of data. But as the cost of launch continues to go down, more and more nowadays it's about the movement of physical assets. Both individual satellites and entire constellations need positioning and then collision avoidance. Debris needs deorbiting, and then reusable platforms and even in-space manufactured materials need returning to Earth. At Proto-Launch, we're developing the next generation of chemical thruster to meet the mobility demands of in-space operations. Proto-Launch thrusters are at least 50% more efficient than the next nearest chemical thruster, and we can produce thrust levels far beyond any electric propulsion system. Being based here at Westcott Venture Park lets us test all of our engines in one place. We've got a state-of-the-art data acquisition system equipped with modular, cryogen-capable propellant delivery systems. A big focus of our work here at Westcott is propulsion testing. So we can actually take our hardware and push it to its limit and beyond to really understand what our engines are capable of. Because of where Westcott's located and the facilities we've got at our hands, there really is nowhere else in the country you can do this kind of propulsion testing commercially.
Our propulsion test facility, located here at eSite on Westcott Venture Park, allows us to rapidly iterate our technology for new in-space markets. We're able to test bipropellant chemical engines down here using our modular, cryogen-capable propellant delivery systems and our state-of-the-art data acquisition technology. Being co-located with manufacturing partners on site allows us to manufacture, test new products right here in the same location. This infrastructure is a critical enabling technology. We can iterate products rapidly and also undertake propulsion testing work for global customers. Outside of Westcott, there is nowhere else in the country that allows commercial testing of this scale.
Hello, welcome to Headbond Engineering. We've been based here at Westcott Venture Park since 2009, and we mostly specialise in testing chemical propulsion systems. So we do a variety of tests with different propellants and frost levels up to about 20 kilonewtons. So some of our recent projects have been on additive manufacture and especially design for combustion chambers for additive manufacture using a variety of metal powders including copper. There's a variety of new nickel-based alloys and some more traditional alloys like Inconel 718. So we have a few 3D printed chambers here which are very lightweight, but primarily these are designed to test heat transfer. So you can see there's cooling channels that run through here, and we hook this up to our test rig and hot fire that. We've also been working on a variety of other techniques for 3D printing, including this, which is a cold spray additive manufacture technique where we're able to develop very high aspect ratio cooling channels without some of the problems associated with usual laser sintering techniques. And internally we also provide data acquisition and control systems for rocket test rigs essentially, which is what you can see here. So this is our in-house acquisition and control system. There's about 5 of us in the company with a lot of background in rocket engine design and testing and various other heat exchangers and all sorts of propulsion test facilities on site. Welcome to our J2 test facility. This is one of the 2 facilities we've renovated from when this site used to be the government's rocket propulsion establishment. We've been making all sorts of upgrades and improvements. Primarily we use this facility for air hydrogen combustion experiments. This facility has state-of-the-art controllers, so we're able to dial in a customer's mass flow requirement to within 1% of a mass flow within a fraction of a second. And we can store up to a cubic meter of air at 200 bar. So we're able to adapt to a wide range of customer test requirements. And all of the experiments here are controlled and monitored by our data acquisition systems, so we're able to provide immediate test results to customers as soon as the test is complete. Welcome to J1. This is the other of our 2 test facilities. Right now we're in the middle of renovating and refurbishing it for cryogenic service, so soon it will be a high thrust liquid oxygen and liquid methane facility. What you can see is our final project, Dry Rock, which is a hovering rocket or hopper. We've been working on this in collaboration with the European Space Agency, so it's able to lift off under its own control, autonomously hover, move sideways, come back again and gently land. And we're using this to research technologies for landing on other planets or the moon. It's an entirely in-house project that we've only recently been given funding to work on, including all the control systems, avionics, propulsion, engine and so forth. And we test that here as well, just outside J1.
Welcome to our site, home of Ura Thrusters, where we're developing sustainable propulsion solutions. What we're doing is we're taking things like water, we're splitting it into its parts, and we're using that hydrogen and that oxygen to power spacecraft. We're really excited that here in this development centre we will be using vacuum chambers to do lifetime testing of those thrusters, powering them continuously for several months to see how they'd react in space. We're hoping to fly these for the first time in early 2024 and then continue that development here at Westcott Venture Park in terms of making those into a commercial product that can be used on spacecraft, eventually replacing the hazardous materials that are currently used to power those systems.
Hi, I'm Jonathan Hirons and I'm from European Astrotech. European Astrotech is a specialist in satellite rocket propellants, and we've been on the Westcott Venture site since 2007. What we specialise in is chemical analysis of all storable liquid propellants used on satellites, and we also offer fueling services to launch providers and satellite manufacturers. We're currently in our chemical laboratory. We've just received, as part of the funding that we got from the local enterprise partnership Buckinghamshire, we have completely refurbished the lab with new fume cupboards. We have a whole suite of new chemical analysis equipment. So we've got a UV vis, a microwave plasma, and kind of a brand new gas chromatograph, which allows us to kind of look for any impurities in the propellants before they get kind of sent to launch site to be used in either rocket engine testing or in satellite launches. We have also just installed a 26 square metre ISO 8 clean room for doing kind of any specific spacecraft hardware handling or kind of prep for our FGSE, which is our fuel ground support equipment that goes out towards launch site, which will be used in clean rooms with the satellite. We also have two hazardous test bays on site, which were old rocket engine test firing bays. We use these for flow testing and pressurization testing. Part of the LEP funding has been put towards actually upgrading our control rooms to make them a nicer environment to work in. And we have also kind of brought a suite of instrumentation and sensors that will be kind of freely available for any customers to use.
Welcome to the new in-orbit servicing and manufacturing facilities here at Westcott. The objective of the Catapult's manufacturing facilities at Westcott is to support space companies build their designs. We have different manufacturing technologies for different space applications, things from additive manufacturing, 3D printing, laser cutter, water jet cutter, and also inspection and metrology capabilities. So our objective in the satellite applications Catapult is to support the UK space ecosystem, and we do so by using facilities such as this one in Westcott. We have different manufacturing capabilities, like the metal 3D printer that we have in the back, and users come to us with a design so that we check that it's able to be manufactured. Sometimes we need to do some design changes, and then we print it using this system. When the print comes out, it's fused to the build plate, so then we need to use another machine, the wire ATM that is in the back, to remove it from the build plate, and then we will have the part. We also have a glass cabinet to do some basic surface finishing. Additive manufacturing allows us to produce very complex geometries and parts that wouldn't be able to be manufactured through other methods. For example, for rocket engines is very, very useful because it allows to have different channels for the cooling. And we also use a material that is able to be already fired and it can be going directly to space. It's called Inconel 718, and that's the main material that we're using in the machine. We're already working with companies here on site, but also in other parts of the UK and internationally, helping them build the rocket engines and other space applications. Our goal at the Satellite Applications Catapult is to support the whole UK space ecosystem, and that's why we work with all types of companies, from small startups and SMEs to big primes in the space industry. We also work with different universities and student teams that are developing their own rocket engines, and they can come and print it here with us. The way we work is that they come with the design, we see the design with the user, we see if there's anything that needs to be changed so that the manufacturing is successful, especially with the metal 3D printer that is a little bit more complex. But we could also use any of the other manufacturing capabilities if companies are interested in using them. Yeah, we're looking forward to support all UK space companies, so please come and join us, come and use our facilities. We will be really happy to help you with anything that you want to print or manufacture with us.
So this is the ISS7 facility here at Westcott. It's a large facility. It's about 27 metres long and about 7 metres wide. The idea about this is to allow companies to come in, use their technologies on our robots to test them out, particularly around close proximity operations and moving towards assembly and servicing in manufacturing in space. The robots are here really just to act as a proxy for the space environment, to give us a microgravity environment rather than trying to do that in a neutral buoyancy tank or the more expensive way of actually launching and testing in space. The room is black. It's black not because space is black, but actually the robots in the room, we want those to disappear into the background, and that's why we have the full dark facility. We also can illuminate it to make it look like the sun is shining at instruments, so we can confuse instruments, see how they react to bright sunlight. We have a high definition projector, so we can project star maps onto the walls, so we can actually try and navigate off the star maps on the walls. We have force and torque sensing devices in the robots, so we can see what happens when the two robots bring satellites together or devices together, and see how what happens to the satellite, how they react, and then the robots will react accordingly. And all of this is backed up by a full control room upstairs where we can monitor, visualize what's happening and control it. But it's not just this room that we have here to support IOSM activities. We also have a smaller robotics laboratory upstairs where we can test out smaller items, test out tools or concepts before we bring them down here and test them out in the main facility. So the facility is available for any company of any size, either from the UK or from anywhere in the world to come and use. And they can come in here and use it, they can work with our engineers. And it's a pretty unique facility. It's large, it's one of the largest in the world for its kind of activities that it does. And it means you've got a big range of motion, you've got a big range of capabilities in here that we can offer that you can't necessarily find in other facilities. So this facility is almost complete. We were commissioning the robots today and they're now signed off for use. We expect the whole facility to be ready for use in Q3 of 2022. We'll always be changing it, we'll always be moving forward with the technology, reconfiguring it for different people's activities. We've got big development plans for the facility, and starting in Q3 of this year we'll start to see projects come through the facility.
Welcome to the Living Labs here at Building 4000 Unit B of Westcott Venture Park, a real-world testing environment where stakeholders from across the health sector and the agri-supply chain can come together to discover, co-design, co-create and deliver solutions for the future. Here we are in the Discovery Workshop, sometimes known as the Garage. This is a real-life testing and demonstration facility. It's where you can test physical assets, real assets in a real-life circumstances. It's where you can actually get hands-on with the technology, put it through its paces and test it to failure. It's a safe, it's a secure environment where hopefully organisations can come together, where they feel they can share ideas and where they can innovate together. So it can be fully tailored to a company or an organisation's needs, depending upon what technology you're looking to test. Here we have the conference room where stakeholders and organisations can come together to host seminars, presentations, share data. We've got state-of-the-art touchscreens and video conferencing facilities. We also have the Spark Room. The Spark Room essentially is the sandbox. It is a brainstorming facility which is designed to ensure that organisations, when they come together, can scope out proposals, brainstorm ideas and do that co-design and co-delivery phase. We've got 4 demo rooms available at the Living Labs. The demo rooms can be mocked up to mimic real-world environments. That could be a farm office, it could be a doctor's surgery, and in there we can actually demonstrate and actually do real-life testing of equipment and actually showcase it in a mocked-up real-world environment. So in the visualization lab we have augmented reality and virtual reality, which can actually be used to create digital platforms. So for instance, with the ambulance behind me, you could provide a digital inside of the ambulance and actually put prototypes and equipment in there and actually demonstrate it without actually having to create the real environment. So what's the future for the Living Labs? The Living Labs are now open for business. We want to attract organisations and stakeholders to come and use the facilities, to take advantage of the ubiquitous connectivity, the 5G systems and processes that we have here. We want them to come and actually sit down and meet with our user-centred design teams, to scope out business proposals, to develop technology, to do it in a collaborative setting, to join our ecosystem and our network of organisations. We want people to come here and host events, we want there to be forums here, we want to showcase technology, and we really want for the Living Labs to be that showcase, to showcase the methodology of what Living Labs can be and how collaboration can achieve true innovation.